Okay, so you don't know this, but this is take 3 of this video because of this thing, huh? Because of him. I'll have to show you the bloopers in some other world. Okay, here's what's gonna be on the test tomorrow. Number 1, find the zeros of the roots or the x-intercepts. And the pen stopped working, so I threw that other pen out. Factor completely, and we're gonna use synthetic or long division for that. Come on, camera. Literally an iPhone 14 Pro. You need to focus. Write the factored form from zeros. Put this over here. This isn't working. Okay. Come on, pen. Oh boy. Turn this. Yikes. Okay. Write the factored form from the zeros. Okay, so here, say I gave you zeros of 4, -3, 2i, and -2i. Well, I need to go back a step in order to get the factors. So if 4 is a 0, x minus 4 is a factor, x plus 3, and so on and so forth, even with the i's. Area model, get an answer. Area model, get an answer. And then area model the answer together. You're going to end up having a 4th degree polynomial. I didn't do that though, so that's up to you. Additional roots. So for example, what if I only gave you 2i, right? You need to know that the other root would be -2i because i's come in pairs and square roots come in pairs too. So let's say I gave you, the square root of 7. Then if the square root of 7 is a 0 or a root or a solution, it needs to have its negative counterpart, -√7, okay? So just know that. You're gonna have to match factors to a graph. So like, for example, if you know x minus 4 is a factor, you're looking for a 0 at 4, okay? Match multiplicity to a graph. Okay, so here's where we're gonna get a little crazy here. Okay, so let me get rid of this. We'll talk about this in a second, I think. All right, so let's do x. Actually, let's do this. I should have had this prepped, but I'm stupid. So let's do x minus 6 squared. Okay. You see how the function bounces on the x-axis because this is the x-axis here. You see how it bounces here? Well, this is multiplicity of 2. The answer is 6 twice, right? Because look, it's got a second power. See that? Well, which means it has to have 2 solutions, obviously. So because it bounces here, that is multiplicity of 2. Bam, right there, okay? So that's multiplicity of 2. Anytime a function looks like this and it hits the x-axis, that number that it touches at will be twice. Okay, let me try a third power now. It might actually work like this, hold on. Take a look at that. Ooh, that's hideous though. Why does it look like that? Ugh. That is not supposed to look like that. Oh, it's because it's 23! Ooh-wee. That's better. Okay, now, anytime a graph looks like this, specifically this, like it goes up and then it kind of sits there for a second and then goes up again, that's multiplicity of 3. And we know it's multiplicity of 3 because the exponent's 3, right? So this is multiplicity of 3. So anytime, anywhere on a graph, if it looks like that, it's multiplicity of 3, meaning that 6 happens 3 times. Now, oh, say hi. Hello. Oh, geez, you're right there. Okay. I know, you're a good boy. Stop though, stop. Now, even if I made this a negative, right, and it switches, it still has the same pattern. Still multiplicity of 3. Okay, moving on. I know, you're a good boy. You're not really, but it's okay. All right, match the min and max to a graph. So let's go back to this one. Oh, do you want to make a function, buddy? He's pawing the computer. Okay, so, okay. So this graph here has an absolute minimum. If the dog stops licking my hand, I can show you. Okay. This is the absolute minimum of this graph. Now, how we normally put it as f of -1.5 comma -2.688, tomorrow's test is only going to show the y value. Now, if I want a minimum value or a maximum value, it's only going to show the y values. So you would just put an absolute minimum at negative 2.688. Okay. You're going to have to find domain and range of a function. That should be relatively simple. Find the y-intercept. It's like literally just click on the y-intercept, so please don't get that wrong. Odd, even, or neither. Use 1 and -1, but I think you'll be able to tell if something is neither because it's going to look funky. Like that's super neither. Like that's nothing. There's no symmetry whatsoever here. And an even function is symmetrical right down the y-axis. So that's not going to be too bad. Degree and leading coefficient. Okay. The degree of this function is 4. Its leading coefficient is 1. This one, its degree is 3 and its leading coefficient is -1. Okay. Basically, whatever the highest power is the degree, and the leading coefficient is the number in front. Increase, decrease, we've done a million times. So that's going to be it. Now, really quick, last thing. There's going to be, I think there's one question. It might be 2 on the calculator. I haven't used this calculator in literally like 4 years. So hopefully it still works. Okay. All right. Let's say we have to graph a function and find out key points of the function. All right. Here's what we do. Hit y equals. It's going to come up with this nonsense. Let's plug a function in. It doesn't matter. Let's do x to the 3rd power plus x squared. Let's just make it simple. Literally, dude, your hair is literally everywhere. It's disgusting. Let's do -2. Okay. See how I put that in there? All right, now we're going to hit graph. And it's going to take a second. There you go, right? So there's the graph. Now, how do we read this thing? There's a button that says trace. If you hit trace, it's going to pop up with a whole bunch of stuff. Now, you see how it just popped up nicely on the y-intercept? So when x is 0, y is -2. That's the y-intercept. Now I'm going to hit the toggle buttons right and left. And it's going to follow it. Now, this part's going to be a little funky. You see how I'm trying to get to the x-axis here? And I'm a little above it, right? If I go the other way, I'm going to be a little below it. So it's not perfect. I'll show you in class tomorrow how to get exactly to that. So you see how this is going to be close to the y-axis because that y value is really close to 0. It looks like the intercept's going to be exactly 1. So I'll show you in class tomorrow, and I'll put it on the board tomorrow on how to do that a little bit more fluidly. But you would tell me that the x-intercept is 1 here, right? Because that's the only thing that's going to be close. And then we would go from there. Like, this doesn't have a min-max, but you can obviously just keep going right and left to get to the points that you need. Now, this doesn't have any multiplicity because you see how it just goes through the x-axis once. So nothing there, okay? So that's how we'd use the graph. You hit y equals. You would type in your function. X is here. It says x right there. And this is the same calculator you use tomorrow anyway. And then you would hit just graph and then trace. And I'll put that on the board. Okay? All right, so hopefully you understood that. One last thing about this graph, because I did say we would go back to it. This graph has 2 zeros, right, here and here, an absolute minimum, and this graph's end behavior, this is the one I want to talk about. As x approaches -infinity, x going left forever, y is going up forever, or positive infinity. As x goes right forever, f of x goes to positive infinity as well, because this function is going up on both ends, right? And we know that because it's an even function. It's not even symmetry, it's just got an even exponent. Okay? Say goodbye, Titan. Bye-bye.